All right, this is 5th grade, lesson 6, and this is on adding one-digit numbers. Also, we're going to learn about a weird word called addition algorithm. Sounds kind of weird, huh? Okay, the first thing I want to talk about, you ready for this, Eli? We're going to work with addition real quick, okay? Something plus something equals something, right? Okay, let's just take some easy numbers. What does 2 plus 3 equal, Eli?
5.
Very good. All right, now, in math, do you know what the answer to an adding problem is called? You may not have ever learned this yet. Starts with an S. Okay? It means sum. Now, it's not like I have some chickens, not that kind of S-O-M-E, okay? But it's sum, meaning if I add up numbers, the equal is the sum, what it equals, okay? Now, these two have the same name, and they're called something kind of simple, add-ins, okay? Because you're adding them, okay? So these two numbers, depending, it doesn't even matter what numbers they are, these two, whatever we choose the numbers to be, are called add-ins, and the answer is called the sum. What is the answer called, Eli?
The sum.
Very good. And what are these two numbers called? Come on. Starts with an A. Add-ins. You did it. Good job. Add-ins. Very good. Okay. So as you learn, you'll be going to learn it in 6th grade, and 7th grade, and 8th grade. Eventually, you'll get it to where it won't even be hard to remember. Okay. So those are called add-ins. Now, if I change places with these add-ins, do I still get the same number? Yeah. Okay. And so when you're working with adding, no matter how you move the numbers around, you're still going to get your same answer. Okay? Even if I have 3 numbers. Okay? This would be another add-in. Okay? 3 plus 3, 6, plus 2 more, 8. Okay? But what if I move this around and went 2 plus 3 plus 3? Think it's going to still equal 8? Yes, it will. 2 plus 3 is 5. 5 plus 3 is 8. Okay? So what that means is, Eli, when you're adding, you can always move the numbers around and you'll still get the same answer. Okay? That in math is called, this is a big word, commutative property of addition. Okay? The commutative property of addition. Okay? And all that means is, no matter how I change my numbers around, what's going to happen? I'm still going to get the same answer, no matter what. You get it? Okay. So now, let's take these numbers, and they're wanting me to find the sum, which means what?
Answer.
2. What kind of problem? Adding problem. Very good. Okay. They're wanting me to find the sum of 7, 4, 3, and 6. That's what they answered. That's what they asked me to do. Find the sum of 7, 4, 3, and 6. What are they asking me to do? They're asking me to add these numbers together and find the answer to it. Okay? So watch this. 7 plus 4 plus 3 plus 6. Okay? I'm going to line it up vertically. We could do it sideways, and that's fine. But I like to do math up and down, vertically. Okay? Now, I'm going to show you 2 ways to do this. One is actually way easier. The first way, which is not easier, okay? The first way is 7 plus 4. Just a minute. Okay, as I was saying, this is the first way you can do it, okay? This is not the way that is the easiest or quickest, but it's still the way that you can do it. Okay, watch what I do. What is 7 plus 4? 7, 8, 9, 10, 11, right? So I'm going to go 11 so far. Okay, so far we have 7 plus 4 equals 11. Now let's add 3 more to that 11. What would we get?
15?
Almost.
16.
11, 12,
16.
13, 14. 11, we're adding 3 more. Even if you use your fingers, 11, 12, 13, 14. Right? So now we have 14. Okay? But now we have still 6 more to add. Okay? So 14, let's use our fingers to add 6 more. 14, 15, 16, 17, 18, 19, 20. So when we added 6 more to 14, we're going to get 20. Now that's one way to do it. Okay? And it works just fine if you like using it that way. Okay? But there is an easier way to do this. I want you to watch what I do. Okay? There are some numbers that you can add that you know we're going to equal certain things. For example, we know that 7 and 3, I already know that because that's one of those sums that I've learned over the years. I know that 7 and 3 equal 10. Which is kind of quick, right? Boom, I know it. Therefore, 7 and 3 equal 10. Now, I also know that 6 and 4 equal 10. 4 plus 6 equal 10. Now, what is 10 plus 10?
20.
Now, you tell me which one was easier. That one, right? Way easier, okay? But all I needed to know is what are some numbers or add-ins when you add them together that equal the sum of 10, okay? And so because I knew that 7 and 3 equaled 10, and then 4 and 6 equaled 10, then all I had to do is add up 10 and 10 to get 20, okay? So it really works good that you can change your numbers around and add whichever ones you want to first or second or third, okay? So that's a way that you can use an example to help you move quicker through a problem, okay? Now, let me ask you this. Okay, I need you to really think about this question. Okay? It says 4 one-digit whole numbers. Just one digit. So does that mean it includes 10, 11, 12, 13, 14, 15? No, because that's 2 digits. 10 has 2 digits. Okay? So they're telling me that I have 4 one-digit whole numbers. So 1, 2, 3, 4. One digit. Okay, so it's going to be a number from 0 to 9, right? All right, so listen to this. I have 4 one-digit whole numbers that are going to be added. Is the sum, the answer, more than or less than 40? Ooh. Is the sum more than 40 or less than 40?
How would I know?
How would you know? All right, so watch what I'm going to do. Let's pick the highest one-digit number. What is my highest one-digit number?
9.
9. Okay. And let's say we had the highest number on all of the 4 ones, on all 4 digits. What is 9 plus 9 plus 9 plus 9 equal? Well, that's the same thing as doing 9 4 times, which is really 9 times 4. Okay? What is 9 times 4 or 9 plus 9 plus 9 plus 9? 36. You're exactly right. It is 36. So it asked you, now we just chose 9 because that was the highest number that we could choose. Okay? So it says, is the sum going to be more than 40 or less than 40?
Less.
Less. We know that it's going to be less than 40 because when I even chose the highest one-digit number, it was still less than 40. If I had chosen the lowest one-digit numbers, well, it's going to equal 0. Well, let's say I chose the middle one. Let's say I chose 5. 5 plus 5 plus 5 plus 5 is 20. So it's still less than 40. So even when I chose the highest number, 9, 9, 9, 9, and 9, it was still 36. So I can't go any higher than that because then it wouldn't be one digit. You see what I'm saying? Okay, so would it be less than or greater than 40, Eli?
Less than.
Very good. All right. Now, there's one more thing I want to show you, and it's another property. Do you remember how I was telling you about the commutative property in this lesson so far? What was the commutative property about, Eli?
What?
Remember? What did the community property state?
What's the community?
Remember when I wrote community property up here? Okay. The community property is when I can change any number around and I'm still going to get the same answer. Remember that? That's the community property. Okay? You'll keep learning it year after year after year and it'll get easy. Okay? All right. Now, this one is the identity property. Okay. And because we're working with addition, this is the identity property of addition. Okay? And all this states is this. Let's say I am number 5. Okay? This is me. I am number 5. And if I add something to it, how do I keep my same identity? I am number 5, and I want to stay a number 5. What can go here?
0.
There's only one number, and you're exactly right. The identity property states in order for a number to keep its same identity, a 0 is the only number that can be added to it. Good job. Okay? That's just what the property states. Not a big deal. It can even be a big number like this. 999. 999, not 999 plus what would equal 999?
0.
0. So no matter what, I want to keep my same identity. Okay? That's what that states. It's not really that extremely important, but it's just good to know that 0 is the only number that's used when you're using the identity property of addition. Okay? Now, an algorithm. Remember that word I told you about? Algorithm. It's a weird name, huh? All it means is it's a procedure that we're going to do to get an answer. So you perform algorithms all the time because you do a procedure or some kind of problem to work to get an answer, right? So it wasn't that big of a word, okay? All right, now we're going to work with money, all right? And it said James had, read this number to me.
462.
$462. That's how much James had. Very good. Okay? And then it says Maria paid James $58 rent when she landed on his property when they were playing Monopoly. So Maria paid James $58. Right? Okay. How much money does James have?
So he had 462.
And then what kind of problem am I going to use to answer this problem?
Multiplication.
Okay? We have $462. That's what he had. And then Maria came and paid him this much. Now how much money does he have? No, don't tell me. I just want you to tell me what I'm going to use.
Oh, adding.
Well, adding. So I'm going to add this. Now, it's important when you're adding that you line up your ones. Remember? $2, $8, $60, $50, hundreds, and then you can even put a 0 here if it helps you. Hundreds. This one had no hundreds, okay? But it's very important that you line up each of your sections because otherwise you'll get it completely wrong, okay? Okay? If I would have written my 58 here, then that says I have $580 rather than just 58. Remember that? Which changes the entire problem. So we don't want to put our 58 anywhere else except where it belongs. The 8 in the 1 spot and the 5 in the 10 spot. Do you understand? Okay. So let's perform this problem. 8 plus 2 is 10. And remember, you carry the 1. This should all be kind of reviewed. Do you remember doing this carrying stuff? Okay, good. 6 plus 5 is 11. Plus 1 more makes 12. And then I'm going to carry the 1. 1 plus 4 is 5, and 5 plus nothing is 5. So, I brought down my dollar sign. How much money does James have now?
420.
How much?
520.
Very good. 520 is how much he has now. Very good job. Okay, and that is lesson 6.